So I would like to just maybe quickly repeat like my opinion about the course. I really like the course, like the designs and specific for high school students. And let's give you an opportunity to know what is AI and taste the AI, and even with some practical experience. And then you make decisions for your future. You can probably decide to be like the person to sell in AIC. Like now, if we consider now is the age of AI, and you can decide just swim. At least like you don't want to be synced. So that's the way. Like also this sections once I have like Paul invited me to this speech, and I'm thinking how I can help you and how I can like bring my ideas on my experience and to support you and for your the current project, current course, or even the future career development. So let's start. Just want to quickly introduce myself. My name is Chun Lei, and I'm a director of advanced analytics in Manulife. We call advanced analytics always like that's the team just want to distinguish with like the data analytics, and we do AI and use AI, use machine learning to help the industry, to help the company. So before that, I have like 13 years experience, and like now like leading the team, leading the projects in insurance, also like in previous like in the bank, and mostly like my work experience in finance area. Like before these 14 years, just catching like the past 10 years, like before that, as I was like in my master PhD postdoc study, actually from beginning like for bachelor masters in mathematics, and the second master PhD postdoc in pattern recognition and machine intelligence. Like I was at Concordia like in Montreal, and for that's quite a few years, and they're doing research at the time, and also have some publications, and have over 15 publications, mainly coming from my PhD and postdoc studies, and also like that includes some books, journals, conference proceedings, and so on. And my last publication was from last year, like still at the time once I was already in industry as director and for the team and my team members, and we have some innovations, have publications, and sorry, in US international conference. And Purvis also have some experience with some as researchers, as visitors, and even like have some MIT speech, and to like a lot of places. Like one of like as a research visitors was I was at Concordia, like went back to China and the Institute of Automation, Chinese Academy of Sciences. And just like I feel it's kind of lucky, and I was like nominated as eventually awarded as the AI expert in 50 under 50 shaping tomorrow at Concordia University in 2021. That's happy to have this honor, and also feel like the passions and to continue to contribute and lead like the people around me to work together in AI. And also have some other roles like in AI, just helping like similar to here, like just have them do some speech, and also as a like mentor for quite a few years for AI for Good Lab. That's all mostly like helping like the girls, like women and whoever's like in machine learning and for their projects and build up their skill sets. So if you have no questions, let's go to straight forward to this section and what I want to talk about for today. 3 parts. And firstly is AI with 6 W's. And like mostly once we start to talk about AI, and we want to know what is the AI and where can we use it, why, who is like the data science, like who is working on like in the AI field, and when should we use it, how. All these things we would like to talk today, like in general. And also happy to hear like you have some, not one-on-one anymore, and you are like, I can consider like maybe 1 or 2, or maybe like you have some experience or already have some ideas. Just want to recall and summarize from this way. And then the key part, I will talk about the real AI applications in insurance company. And specifically now, like I work quite a few like different companies, insurance companies, and have like different experience and focus on different stuff. And we'll talk more details there. Last section going to be open discussions. It all depends on the time and see if hopefully I can just wrap up as soon as possible and give you like enough time for discussion. If we don't have enough time, and we can still like, you guys can send message to Paul and we can continue have further discussions from there. All right, so let's start from AI with 6 W's. Everything like specific, like in mathematics, we always start from definition. We need to know what is the most important thing. Like once we talk about AI, what is AI? Artificial intelligence, right? 2 words. But always this is like what we call artificial intelligence and what it is able to do. So just imagine like without like with the words to define it, and just imagine like intelligence, and we have intelligence, right? As human beings. So what's the difference between artificial intelligence to human beings, humans' intelligence, and why we want to have this artificial intelligence. So this is like really the way, like initial, like the reasons behind we do AI. We want to simulate human beings, like humans' intelligence, but not like with machine as like the tool to help us, but how we can interact with machine, we have to do some programming, like the coding. You guys already have this experience, right? So that's eventually like the target, like the objective of this one is we want the machine able to think like humans, or able to mimic our actions. So the machine able to replace or help human beings in such a scenario. This is the definition for AI, artificial intelligence. I may like just highlight again, we want to do the simulation and simulate human beings' intelligence. How? Like use a machine, and we can just bring machine here, and the interaction is by coding. And eventually the target, the objective is to that machine able to think, able to do the actions. Is it clear? All right, so once we have this definition, and I think that from mostly people like in normal life, people think about AI as a black box and always like don't know what happened and just consider as a magic and from input to output. And now we can just start to peel like what exactly like the black box, like what's inside of the black box. So from data scientist, like previous, like I was a data scientist, like starting from data science senior, data science lead data science until like today as a director data science, lead the team with all data scientists, some machine learning engineers. So what we see, what is AI, what is machine learning? That's really a treasure box. Have scientific methodologies able to advance the computing, have data engineers and hacker mindset, and have domain knowledge and so on, a lot of things, and able to be there in the black box. So we'll talk more details like one by one. Let's go to next page. A lot of confusions, people like, a lot of people even ask me like in general, like in life, what is AI? Like what's the relationship between AI to machine learning, to neural network, to deep learning? And like so now, I think deep learning now is so popular. A lot of people talk about, like especially in the past few years. Actually, that's not anything new. Like it's so many years. Like I think probably around 20, 30 years. And like in research area, we know this one. And so, but people just have no idea what's the difference. They think they are equal. Not really. So here I would like to show this way and just thinking like the relationship. Artificial intelligence, AI, is like the biggest one. And just now forget like data science or big data and just focus on like the blue ones. Artificial intelligence is a big one. Just imagine like as human beings, like the entire body, that's the artificial intelligence. What is machine learning? It's our brain. Like what you think, make decisions, see the insights, trigger strategies, all these things like that's made by machine learning. So that's, you can simulate like AI, including like even some actions. like you have some robotics with some hardware, or like able to do some actions. But machine learning, no. Mostly we just do coding every day and with the data, and you see like even trigger actions and maybe just triggered by data, like to maybe send email or like maybe send message, maybe just from data's perspective on the dashboard. We don't do the real action works. What is neural network? That's just one of the methodology, or as just Paul mentioned, like that's an algorithm able to do the prediction or forecasting. Well, actually in machine learning field, we have so many algorithms. Neural networks just one of them. But just because of like deep neural networks, it is so popular now, everyone talk about this. But actually, like we have like super vector machine, we have like the regressions, like even like, I don't know if you guys hear about like linear regression, or the simple one. That's part of like the in machine learning have different all kind of algorithm to facing like to solve different problems. Neural network is just one of them. What is deep learning? And I'll say deep neural networks. That's also just one of the algorithms in neural networks. And the beauty of this one, and also that the reason make it so popular, is they're able to detect or extract features for classification or for like the prediction automatically. They reserve like the most important features or information, able to do automation. So then people realize, okay, I give you a picture, and then you can do the classification immediately, or object detection. I don't know how. And also I don't need to do any pre-processing. That's the beauty. And so that's why this also so popular. But that's only just use like the way to do the automation for features, and then plus neural network like classification or regression. So that's really the way like you see from artificial intelligence, machine learning, neural network, deep learning, or even now have all kinds of like even detail, like more granular ways to see like deep learning with all kinds of algorithms. So that's the general like way. Data science is actually, that's a new term, like in most, I think, maybe 10 years, 20 years, even big data. They are almost at the same time, like in parallel. And artificial intelligence and machine learning, that's even including pattern recognition. That's the really old terms, like for so many years. So data science is somehow similar to like machine learning, like sometimes even like in my team, we call advanced analytics. But some other companies, like what previous ones I was in Canada segment, we call data science team. So it's kind of similar, and not that easy to say like how exactly like the difference. But mostly like data science is kind of like we consider have like the big data platform, or like really the volume data is already there. And then we do some scientific way to do some forecasting predictions. And so somehow similar to use the machine learning's way. Big data is also like just now because of like the storage or like the speed, like a lot of things able to guarantee or help to support like data science or machine learning's algorithm able to run in a bigger platform and with a acceptable speed in industry to solve the real applications or use cases. So now like people even able to find like jobs just in like the data platform, like data field. So that's general like the relationship of AI family. Let's go to like why like machine learning is so hot. Like people talk about this, everyone talk about this, and just thinking like two scenarios, like in the real life, like maybe we didn't realize, or maybe you have already realized, and that's everywhere, like in our daily life, like with the machine learning's algorithms applied. Amazon with Alexa. That's the one like this. You are able to do some speech like interactions, right? So one example of this one I really want to mention is that's so great, like a product. My younger son, that's once probably a few years ago, like my friends just bought me Alexa as a gift for my birthday gift, and I just feel that's not that useful, but I'm happy like have this gift. until my younger sons start to use it. He talked to Alexa a lot, ask questions, and like ask jokes, and just entertain himself. And also he know like whenever I order like in Amazon, before like coming back home, he has already know what I ordered. He used Alexa to call mom. And sometimes I just receive phone call, surprise I heard from him, and who has no phone at all. And I find he's the person, like even start before he's able to do writing, reading, and he has are able to use this one to make himself happier and really useful to change his life. So like also able to like now if you go to like go to hospital or go to clinic and you like always taking pictures, right, from dental, like x-ray or whatever stuff, all these like also able to use AI to do the automatic, to do some abnormal detection, or like to see like if that's normal or whatever, like if any disease or anything. So that's in medical, we also have these like applications. And also like some like videos, you see video cameras everywhere. I think like even at home, like surveillance cameras, this also able to like now it's just recorded, and I don't think like you have any AI techniques behind. But if you do some detections, that's something like really machine learning algorithm behind it. Email spam filtering, and that's if you have the Gmails, like you have already seen that every day. And so that's just has already embedded like all like already in our life everywhere. How about enterprise, like now like in industry, how we see like machine learning able to help? That's also like the reason like machine learning is so popular. A few like just a few examples here, and we'll talk more use cases like later. Like customer support, and just imagine like in either also even insurance or like the bank, and you have the credit card, and the fraud detection. Like you don't want like someone else use your card, right? And so all these like the detections and some any abnormal actions and able to be detected. That's from machine learning. And also like we do customer services and support like the call centers. And actually the pictures here is really beautiful. Like you still have the person, even you see like that's not real person, like still have some person's shape. In real life, like in the real applications, actually that's just data and you don't have this at all. But still, like that's able to, like one of the project I would talk about, like once we applied like machine learning to call centers. And like whoever's call start to complain, and the call centers people can immediately run this person's end with to see if how likelihood this person going to say bye to this company, or what kind of products and is more like recommended to this person, and a lot of things like behind. And people once they talk, and you think that's still human beings talking, and just with enough domain knowledge, actually possible to has already used machine learning to help. Recommendation systems is also everywhere. I think like once you buy something like on Amazon, and you immediately see some related products recommended to you. So that's the recommendation systems. And I think now in digital world, like whatever you buy anything online, and that's any companies applied the algorithm. All right, so let's talk about like where. Like where can we use like AI? Actually, I say like everywhere. But let's start to see like the data, like whatever data is ready, is also like I say, machine learning is ready or AI is ready to apply to the industry. How we see this trend, and just starting like from 1980s and see 2020. And like the data, like starting from 1980s, like from the governance, they start to collect the data, demographic data, and like we have always received like the surveys from Canada revenue rate, and about like your family members and so on, and all these data is collected and since 1980s, and then we start to have like the front bank all the transactions, and have like the governance agencies, also like the regular surveys. A lot of data like CRM, like the customer relationship management data, wholesales, like the utilities, like the bills, like whatever we do, and web navigation, videos, components on the web page, social media segment, like the human activity and health data, app user data, like Internet of Things data, like homes, cars, and devices, like all these data, like now we can collect everywhere, and also like kind of a trend in industry or in like in say like in government start to collect these data. The same time, and we see another trend is the cost of data storage and processing, cheaper and cheaper. Like it's just now, I think like everyone's like can really have a really good package, like with your phone, have so many gigabytes, right, with a relatively cheap price, just because like the cost of data storage or processing, like is really guaranteed you able to have more data stored and processed. So that's two trends cross each other. Eventually can really give a field and for machine learning or for AI to grow. So let's now talk about who. Like who is a data scientist? Like the picture here, like people always say like once I grow up, I want to be, people mostly want to be a hero, right? But now more and like most recently, like gradually, like I start to hear people really want to be a data scientist. So that I would like to let you know, like who is data scientist? What kind of skills are looking for? Eventually, like you can make decision if you want to be a data scientist or not. Let's go to next page. Data scientist is not easy to be. I would like to say here, I like list like must-have skills. That's I should say like in our daily life, like data scientists really, really need all these skill sets be ready and to work as I should say good data scientist. Everyone can be a data scientist, but if you lack of some skills, just not easy for you to work on it daily. All right, first thing is mathematics, statistics. Let's give you like the foundation, like the in theory, and for machine learning, and like even some, like even like in once we say pattern recognition, we talk about like statistical pattern recognition or like the structural pattern recognition. So statistics also like really give a backbone and to machine learning. We also need to like able to explore analysis, cluster regression analysis. Like that's really just give you like you need to understand like the formula or algorithms or equations behind the models. That's really the backbone. Second part is the programming or database, I should say. Programming is like you guys have already had this experience coding it, you know the feeling. And that's the way you interact with the machine. And machine only able to, at least so far, probably after the ChatGPT, like you gradually like even not necessary to code like this way, right? And but traditionally, and you need to interact with machine by coding, by programming. And also database, like you have a big data, as I mentioned, like so many data, like you want to query something, you want to know how things look like in general. And you are able to call from Python and to see loaded to data frame, but takes so long. And really mature techniques in database, and people able to do the queries quickly, easily, and immediately see the results. So that's also like you need to have this skill sets. Data visualization, that's also you either from Python, like a lot of visualization tools, or maybe you just from like the dashboard and you just see like just build something like to able for you to visualize, or even Excel files, and you can see like the charts and the graphs and the figures. So that's one of the skill sets as data scientist. And the third one is domain knowledge or soft skills. domain knowledge. What's the meaning of domain knowledge? Just imagine you know mathematics, you know coding, and then you may ask yourself what kind of questions you want to solve, or how I can help like others, like the to solve the problem. And that's just like what I will talk about, like insurance. That's you need to have the ideas or like the domain knowledge in insurance, because you want to solve the insurance, like the problems in insurance, and you need to know what they do, like their daily life, and mimic simulation of human intelligence. So you need to know like what is human intelligence based on their experience, how they solve the problem, and then our machine able to simulate. Communication, visualization, that's also important. I remember one of the co-op students went to my team, and the first time I brought him to a tea time and to just talk to like all the team members and like most data scientists or machine learning engineers. And I asked him, how do you feel? And he said, well, I feel data science is more talkative than I thought. I said, well, that's supposed to be. Like data scientists like really need a skill set, like able to communicate, able to tell stories. Like what you want to do is use your machine learning to help one of the domain solve the problem. Eventually you want to persuade like the leaders, bring them the insights, trigger the strategies, take actions. And if you can't interpret your results, explain it well, and that's nothing. And every work is equal to zero. So communication is really important. And also visualization. That means like you need to find a way to let people able to see your result. Also, kind of like you don't want them feel like data science is so boring, although that's scientist. Just imagine like my today's presentation, if everything is with a table, with a bullet, 1, 2, 3, 4, I'm okay, I'm able to. But how do you feel? You may just maybe stop like to listen to me like in 5 minutes. Now I can see you guys. I don't know if you're still follow me, but at least I try my best and to show like how like to interact with you out, like you feel something interesting. So that's really the way as a data scientist, you like what you need to prepare to be a data scientist. But for myself, I feel that's not enough. At least like my team members, what I expect them like in the interviews, even I would like to see if they really have passions to work in this field. Also, you have to have in what you do. And always ask questions like driving the actions with why. I'm the person always, I said, I'm really a troublemaker, not troublemaker, like at least like the persons keep on asking why, and to team members, and whatever they finish, I may ask, so what? And so all these questions need to keep in mind, and that's eventually can trigger your like what you want to do for next. And so all these things, and that's as considered as skill sets, or like really what we need and looking for as a data scientist. Last sentence I showed here is, it is not a work, it's we need passion. That's really important. At least so far, I never feel tired or like to feel boring like in my life, like in my work, and feel every day have so many new stuff and learn or to solve the problem. So happy to be like one of the roles in this field. And also like when should we think about AI or machine learning as like a job? Here I just give a like really simple like two small images. One is from Harvard Business Review. That's in 2012. That's one of the articles say data scientist the sexiest job of the 21st century. Another papers as also like the same topic, just changed from 21st to 22nd century. But that's the papers coming from like towards data science, and also in 2019. And the funny thing is, like once we see this one, and just along the time, And since people have the same comments, and like in the past few years, that's the same thing. And I don't know, like maybe 2029, and maybe we can see like the same topic, like same title, but maybe just change from like to 23rd century. I don't know. So at least like what I see is people consider this a long time is a job able to continue and to have innovation contribution, and people they think is really hot or like a promising work, a job and to work on. All right, so that's really consider an advertisement for AI, right? Or maybe machine learning. And so now let's go to next, like how, like what machine learning, let's go peel like the black box. What's inside? So I like to use like the simplest way to explain it because yeah, for high school students. And I think if I just give you like the equations and I don't know, like will be like maybe too much. Let's use a way to just matching to our daily life, and you can understand what is machine learning do. So that's exactly the same thing. You see like the upper ones, you do like maybe the pasta, and the second row, that's for machine learning. We do the same thing. And so just imagine like once you prepare like for pasta, and you need to starting from like maybe today my son likes the pasta so much. You want to have like the chickens ones, or you want to have maybe like macaroni cheese or different stuff. And even like same things from like starting from the flowers and eventually to like with different shapes. You need to know and what you want to cook, and you know the ingredients and you prepared. And you also need to prepare, like you need to chop, like even chicken, how to cook and what kind of the shape you want to have. And then all these things like you do similar to in machine learning. And you have the chicken first, and that's the data. And your data engineers and doing like some data cleaning, like you need to boil it and chop it. Like that's the data engineers or data cleaning, or with the feature engineering, like just massage and make it ready for cooking. And what's the ones with like the red box, that's the key part, cooking techniques and like how you want to cook. And this like this pasta is also, that's how we want to do with machine learning. What kind of algorithms you are looking for, like what the result of the problem you want to solve. And also always like you can't just with imagining, like you need to have some like the containers, right? And the same thing like in machine learning, we need to have the architecture, we need to have the tech, we need to know like where's the data stored and what kind of platform able to provide it. One more thing is missing is like the chef expertise. Let's match into the domain knowledge expertise as well. Like you want to cook this way, and then you need to know how, like what kind of stuff you need to, how much you need to put, or like the way. So the domain knowledge, as I mentioned, people's insurance company, like they make decisions on pricing and they sell the like the products. They are the domain experts. So that's the way, and matching to like from cooking to machine learning. Hope that's clear for you. Like if not clear enough, at least like you have some ideas about this, we can go to more details. So in a real AI project, without thinking of the cooking, and have quite a few steps, and still able to match in cooking, or like maybe we just imagine with like the restaurant or whatever. First, we need to understand the business, what they are looking for, and that you know the objective, what the problem you need to solve, and then you prepare the data. Like I always consider to be central. Like you always need to have just kind of like cooking with rice. Like you need to have rice first. So data is there. You need to understand your data, and you need to also then do the choppings and prepare the data, and also like once you do the model, and then see how's the model results look like, and to evaluate if that's good enough, Deployment means like it's on production, able to run there every day automatically. So I don't know if you are able to understand from this way, and also like always not just one direction to go, always have interactions to each other, iterations and so on. So once it's done, we never consider stuff on production as done. We always have a new release, have enhancement, maybe new features, new stuff, and just continue have a loop. We call it life cycle, continue to loop this way. If we imagine like in the real life, like one of the use cases that we can think about this one is just in a restaurant, like you ordered in the menu, and that's you give this one to the kitchen, like whoever's like will cook for you. So they should understand like what you ordered. So then they should start to prepare like the materials, like the ingredients, and then do the preparation and the cook. And after cooking, and they probably they need to bring it to the customer to see if it's okay. Is it the ones you are looking for? And maybe this is too salty. And next time you probably decide, or even like this, can't accept it. And they say, oh, so they say, I don't want any salt. So that probably something wrong from the beginning. You didn't understand business correctly, like the order correctly. You need to go start from beginning, and you see the loop here, like the arrows back to the beginning. And that's a sad story, but it's really possible to happen in the real life. That's also we want to try to avoid. But sometimes maybe I say, okay, it's salty, but it's okay. We are able to accept it. Like, just let me start to eat, and you consider deploy it, put it in the plate, and give it to the customer. They start to eat. But next time you're going to say, okay, I will just avoid too salty and just use less salt. So that's an iteration. So hopefully this example give you can help you to understand like the whole life cycle of the AI projects. So first thing about data, like as I mentioned, that we need to do the cleaning, and we need to do the exploration, prepare data ready for modeling, right? Data in real life, you just can't imagine how dirty it is. A lot of missing data, some inaccurate data. Like we need to work on it. So to ensure the data quality is good enough for the next phase. And one thing, like a trick, like a tip for everyone, like specifically if like in industry, like the new grad, like to the industry, I always tell them, don't spend a lot of time on your models, like your algorithm to improve, to boost your performance. Something mostly like if your data is clean enough or good enough, like can boost the final result much more than you change the model. So then the data scientist like always work as a data engineer or like as a machine learner, work a lot with data to ensure like the performance. So that's really important. And the features, this part is sometimes people confuse with like, what is data versus features? Let me explain here. Just imagine like if we want to describe an apple, what can we do? Is it the color, the type, the shape, like a lot of things that can to describe just one apple, right? These called features. And these features able to help you to prepare, like just imagine in a table, we talk apple 1, and this color like red and green, and fruit, that's a fruit, and the shape is near circle. And maybe we can also have another like orange, and the color is orange, and the type fruit, and the shape, and so on. So just use a way to describe the product, or like the component directly. So that's called features. So here, like I just use one way to describe, like even we call all of them as apple, but that's not the same thing. It's so obvious, like 2 of them, that's fruits. Why is the logo? So if we just imagine, like we want to distinguish apple with orange, probably color is really helpful, right? whatever the color is orange, that's orange. And whatever is not orange, that's apple. Just imagine only 2 classes. But if this one is out of the apple, and maybe we need to just use type to distinguish apple that's really from like the logo, or that's the real fruit. So all is able to like represent the component itself, able to distinguish 2 classes, like 2 different stuff, are able to cluster, like to see like something in common within one class. So that's the features we're looking for. But in the real life, in the real case, it's not that easy to find like really beautiful features and able to classify it very well. Always here and there, but always we need to do a combination with all these features, throw them to the model and do the forecasting or prediction and to do the classification. So let me go through like the entire machine learning workflow. And as we mentioned, like we have like the features structured, we say starting from input, like the data, do some cleaning, features there. And then we do algorithm. This algorithm, like for modeling, machine learning, mostly, I think maybe Paul has already talked about this part previously in the previous sections. And we always need to split training and test, like even like in the existing data set. And like the future ones, maybe unseen ones, and we can just leave it there. We always call like actually that's the real tested data set. But whatever we have in the history, we also can't train all the data in machine learning. Or maybe one more thing, like before that, I just explained, like mostly in machine learning, like we do is always use the existing data, either like maybe in the history or the current status, and to do the forecasting for the unseen or future ones. That's the machine learning able to do or always do. So that in the history or in the like existing data, we always not use all of them to train a model. We split to training and prediction, always a training or validation. So the training part is always like probably 80 or 75%. It depends how's the volume of the data set. And to train and find a really, I say, good parameters set, able to do the prediction well in your validation, and then to do the forecasting, and we just keep it for the future unseen data. So that's the way of machine learning to work out. Just maybe quick check up if everyone's okay with so far. How's the speed? Everybody's okay. Any questions?
Is any questions?
Yeah, deeper.
Any questions you guys have? If you have a question, I can pass back to you. No? No question? Okay. Okay. They don't have questions. It is okay. Yeah.
Yeah, either like I'm good enough at everyone able to follow me out. There's also another possibility is like nobody can follow me and just have no question. But anyway, let's just continue. If you have any questions and anyone like able to stop me and just let me know. All right, now we go deeper. Like once we talk about treasury box, right? Machine learning, and what exactly we can do. Generally, we consider as supervised learning and unsupervised learning. Just most recently, I will also add like the re-enhancement learning as like third top category. So let's talk about supervised and unsupervised first. Supervised learning is like just imagine every day now you are students at school. You have teacher teach you how to do this, and tell you like like some knowledge techniques and so on. This is supervised learning. Always have teachers there tell you like labels. Like just imagine once you're born, you don't know what is apple, which one is apple, which one is orange. Your parents keep on telling you this is orange, this is the apple. Until now, you don't need to ask your parent. You are able to tell this is apple or this is orange based on like your past experience. Your parents has already teach you enough times. So this is supervised learning. And this supervised learning always able to solve two categories of problems. One is called classification, one is called regression. If you see like on the top, this is classification and this is regression. So what is classification? Apple, orange, that's the ones I just mentioned. That's a classification. You know the class, like you have, you say how to identify this is apple or this is orange, two classes. If I add you a pair and you never seen it before, and then you can reject it. You say that's not, none of them possible have three classes, but third one is not pair, it's just rejection. So that's always like to tell you like the number of classes, like you can label them as like numbers of classes. That's called classification. So regression is also supervised learning, and that's different to classification. Is the output, like once we say apple and orange, that's two classes, so clear, like just two kind of different fruits. But just imagine like the output is a continuous number. Like we say temperature, possible would be 22 degree, 22.1, 22.01, 22.001 degree. So that's really a continuous number. If we want to do the forecasting, and we can say this is like class 22 degree, and that's 22.01. So that's, we just give a number continuously and still able to do the forecasting with this, with the output. Mostly the difference between classification and the regression is the output. One is existing numbers, the other is like just continuous numbers, like unlimited, infinite. So that's the supervised learning with the teacher are able to label them with different outputs. Unsupervised learning, so always no teacher teach you, learn by yourself, or learn from just based on like the by nature, like the properties of the products or with the materials itself. Just imagine you never seen a fruit, but you like, okay, so since you are little up to now, you know so many fruits, right? And once I give you an unseen fruit, maybe from somewhere, maybe from South Africa, but you mostly like you're still able to tell if that's fruit or it's eatable. Why? It has some properties similar to like in your mind about like the definition of fruit. You're able to cluster this one to the fruit, or like something is similar, and to something like based on the itself, the property. So like in the real world, a lot of data we don't know if are able to classify, label them with two. Even like you probably don't know what it's called, you can label it 1, 2, 3. But sometimes you don't know how to define it 1, 2, 3. So then we use unsupervised learning, cluster them, and see like if some less based on certain features and they close to each other, far away from others, and we consider this as one of the cluster. You're still also able to label it maybe 1, 2, 3, but most that's you give it. You can call this 1 or can call this 2, just because of the property. So that's called unsupervised learning. Mostly we talk about clustering, much more than dimension reduction. Dimension reduction is like the ways here they consider as part of like unsupervised learning, just like use some unsupervised learning techniques and to help with like a dimension reduction. Generally, we really focus on clustering as like main part of the unsupervised learning. So that's supervised and unsupervised learning, two component, big one. Reinforced learning is like just like now people like consider as like the third category. One of the examples here, maybe I think most of you know AlphaGo, like human being to do the chess, and with like AlphaGo with the machine, right? And the machine eventually be a winner. So that's the use reinforcement learning. Like I do one step, and you do all these kind of calculation or analysis to do the focusing. What I can do the next step, and with like if I do this way, and how much award, or how the penalty is, and to do the calculation. And if I do this way, and how much award or penalties, and eventually like how's the way to go. So that's the reinforcement learning. That's one of the use case of that. So that's in general, like we talk about machine learning with like the algorithms and here and there. So yeah, I would like to ask you to remember at least like supervised learning and unsupervised learning. Especially for supervised learning, a lot of use cases, like in the real world, classification is so important, regression is so important. Classification is like the output should be like existing numbers, and regression always like continuous numbers, like the infinity of the output. And supervised learning, we always talk about clustering based on like the property itself and to do the grouping. All right, so that's really the key part, like really the stuff in the treasure box. Let's go to next step. Like as I mentioned, like once you have the model able to do the prediction, is it means like that everything done as a data scientist, and we just wrapped up, like say that's it. I don't care like the result, how's the forecasting performance, or like how you want to use it. Or I can give you the performance, tell you the evaluation, but still I don't care how you use it. Previously, or at least like at the beginning, once I was a data scientist, it's true. We just give it, throw it to the customers, to the business, to the stakeholders. And they come to us, or they sometimes they say, we just don't use it. I don't know how to use it. So now data scientists take more and more responsibilities. We explain or even visualize the output, interpret it, tell you what you can do with my result, and or even tell you what we can see from data, digger it, and tell you what's the next. So like just imagine like this, I give an example here. The upper part, that's the like the actually like you see, if we see rows, that's we can see that's, oh, this is like the example for red wine quality rating. The output here is the like the numbers possible to be 6 or 6.220. I can't see any students there. Just wondering, how many of you think that's a regression problem? Or how many of you think that's a classification problem? Is it possible we can collect this information? I'll give you a second to think about this. Even if I can't collect this information, can't see you guys.
Okay, guys, just look at blackboard. Okay, you can see blackboard. So which one is classification? Which one is regression? Classification, which one is a regression problem?
Do you think that's the result, like for this prediction for red wine quality rating is a classification, or that's a regression? How many of you think that's a regression? Or even maybe Paul can help me, like see how many can raise hand to think that's a regression.
Anyone think it's a regression or a classification? What do you think? All right, so what do you think? Huh?
What is regression?
Regression or classification? So
I heard
Come
regression.
with,
Did I hear correctly? Someone mentioned
he said
regression.
so what do you say? You pick up one or no? He said it's classification. One
Okay,
student said classification.
all right.
How
Anyone
about
think?
others? Okay, continue.
All right, so most of you think that's classification. All right, let's go back to this one. Classification, when we talk about the apple, orange, right? Like two classes. Regression is like the output should be able to be a continuous number. Come back to this one, like the prediction, able to be 6.2, 6.18, 5.61. That's the number. It's possible even like now, probably I stop with 6.20, but possible to be 6.2001 something. So that means the output here, I don't know how many. So whoever think that's classification, do you still consider that as classification?
Okay, so after explanation, what do you think?
Classification.
So it's regression, right? Okay, so right now he says after explanation, he agreed it's regression.
Good,
You hear
that's
me?
good. It's
Yeah.
correct, right? Yeah, this is a regression. So I just want to like recall like what we just explained and make sure everyone understand. So once just thinking rating, you can give a rate if 1, 2, 3, 4, and also sorting it. And mostly like we consider that's maybe only 1, 2, 3, 4. These 4 classes is okay. Maybe you can do classification, but still, one is better. Like what? If we say like the number is bigger, that means good. Like one should be not as good as 2, 3, 4, right? That's kind of the way you have sequence. So we always expect to do like regression, like specify these ones, like the rating able to be a score, not only just like an integer, able to be any number, then we consider it as regression. This is so important. Why? If that's regression, even you Google search online, the algorithms you use is not the same as classification. And the model you choose have to be the model for regression to solve the regression problem. And the model, if you consider this a classification, you even choose not the same model. So that's why I want to repeat this part. So important. In supervised learning, regression and classification are not the same. That's also can determine what kind of model you want to choose. All right, so let's come back to this table. Like the right side, like the last column is the prediction result. Before that, all is from the first column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, probably around 10. All these ones are features. What's that mean? Just not quite sure if everyone understand like what I talked about in the past. Let's just from this one, let me explain. Hopefully this one that can give you more ideas. These are the real numbers you detected from each individual component, like each individual stuff. Like just imagine the first row, 1575, stand for one of the red line, one bottom here. And you just able to do all kinds of tests and measure them, write it down, all these numbers. All these numbers are the first row from first column, like 7.5 for acidity and 0.520 and for, like this is the first fixed ones. And this is volatile. And all these things until like the last one's alcohol. all these that's measured by the person. And if just imagine you have so many bottles and also many drinks there, and you just measure one by one, you write all these numbers in your table up to alcohol. All these that's already existing in your database. You just have like the training, just imagine you have the model, it's there, and you just applied this model to this table, able to tell you the prediction result. The bottom, like the right side, the last column, that's from your model. Tell you the first ones have the highest score. The rating is the best. Which one is the worst one? The fourth one, 724. Like this one, give the quality of the rating is the lowest one, 4.67. So that's your prediction result. If you give this table to your customer, tell them, okay, this is the ranking. You buy the first one, like, or maybe you can sell 1575 more expensive because the prediction, like the rating is much higher. And then 724, like the fourth one, cheaper because the rating is lower. It's good. You can tell your like your business, like your customers this way. And for data science now, we are also have one more step. Is just tell you all these columns, like these factors or features, which one is more important? And we just draw this one. We use the SHAP value. You probably don't need to understand like the theories behind. Just remember SHAP, SHAP. I just want to let you know. I'm like, as a data scientist, we are able to ranking all these factors. Tell you the most important factor to influence your prediction result on quality rating is alcohol. And maybe the question you like the customer may ask you, okay, alcohol is so important. How important? So you can see, like you can also find a way to draw and to tell. So from alcohol, you see if the alcohol, I think that's a degree, like if degree is higher than 10.8, maybe here should be 10 point up to between 10 to 11, 10.8, if higher than this one, it always give like the better quality of the red wine. And you also can tell like, okay, so if lower than this, then always give like a negative contribution to the rating. So you'd better buy the alcohol higher than 10.8. Then the rating always better. So that's just the way. And also like you can tell, okay, so, and they may also ask, okay, so for 1575, the first red wine, I give this prediction so high, and why? You also can explain, just see one alcohol, like one wine, and which factor contribute to the rating. So a lot of things, like you probably this part you don't need to understand all like fully, but just let you know, as data scientists, we really shake hands and even hold the hands walking together with business. That's a good data scientist, a good way to go, and in the real life, in the industry. All right, so let's go to like the last page here about like tools we always use. Always have selections for data scientists on machine learning, some virtual machines, tools, platforms here, and these like small icons and just stand for different components. Mostly like actually like we use Python now more than like R or C++, Java, and so on. And also like platforms depends like different company. Like in my company, we use Azure. So yeah, a lot of the choices now, like just see how can help you to work with more efficient way. All right, so let's go to this one. That's I see the time. Let's focus on like why machine learning able to help insurance. Insurance, we care about like the risk models, and we care about reinsurance and underwriting and like the new business. So just imagine like if I sell you insurance and I want like you, like I can earn the money, right? And like whatever you give it to me, like eventually you maybe pay 50,000 total, but for life insurance. But once you pass away and I need to give you 100,000, that means I need to pay you more than you pay me, right? But why we still have insurance company? We always do like, I use your money now, like what you give it to me to do investment, or like to do something else and to earn the money enough. And eventually once I predict like now you are 20 years old. I predict like you're going to pass by like maybe 90 years old, 70 years. And I can use your money 70 years if I can guarantee like I can earn the money and I can pay you more. Like probably I earn maybe total 200,000. I give you 50,000 is nothing. I still have more like monies in my pocket, right? So that's the insurance way. Like so, but something we have to keep in mind. Like I need to make sure like now you are 20, and my prediction you're going to pass away at 90 years old is also accurate enough, or generally is good. Just imagine like something happened like in 2022, like 22 years old. I guarantee like I have to pay more. So I like based on a population, and like at 20 years old who ever buy the insurance, and mostly like they pass away maybe around 18, 90 years old. And I can pay one case, but not all the cases. So that's what the insurance company do. And what kind of data we have? We have a lot of data, like in insurance. You just can't imagine. People like always ask, how come like a data science can help insurance? Just imagine like the data is like in insurance companies, and we have customers, and customers all the informations, like your payment to the insurance, and all these tables, so many things there. We call it structured data in tables. We also have unstructured data here. Like I really want to have this definition for structured data and unstructured data. Unstructured data means like just imagine, well, from the word you can see that's unstructured. Text, files, with a lot of freedom. Images, like the 2Ds, like really pictures, different sizes. Speech, like that's just considered as signals. A lot of things, like even insurance companies will have. Imagine like the documents. Whenever you have like the insurance and with the government or whoever, like will sign a lot of governments. Once you have the payment, you have receipt, like your statement monthly, a lot of documents there, right? Images. Once you go to dentist, you have the X-ray, and you do the claims, and to the insurance company pay you. All your images we archived, and like we'll have a lot of images there. Speech. Once you talk to call center, you call them, and they may say, okay, we're going to have like a recording for main training purposes. We'll have all this speech as well. So from speech, you can tell like how's your tone and how's your personality, like a lot of things we can do. So that's kind of data we have in insurance. We have structured data and unstructured data. And that's really guaranteed us to have a lot of fun there. So let's go to next. Data science is like what we can do with this structured data. Let's talk about structured data first. As mentioned, like in tables, right? Marketing. That's we always able to use, like just imagine like once you have your like have insurance, and we collect all this information in the table, and what we can do behind you, we can calculate this person, how likelihood or how the percentage this person going to say bye to our insurance company. This person probably will persist. Even you don't need to just call them. Or maybe sometimes we say no call, don't wake up the sleeping bear. just keep quiet. They just pay. They didn't realize monthly. Do it. Let them do it. If so, you call them, tell them, okay, I have new products. We just do the calculation. Probably that's more important. That's probably more suitable for you. They may think, okay, oh, I still have this one. I should stop it. Probably stop it. Sometimes they may think, okay, yeah, that's a really good one. That's really helpful for me. Like, yeah, let me change. You don't know what happened. Who can tell you? AI, like machine learning, able to do the forecasting, tell you these guys really high risk going to say bye to the company, to our insurance, connect with them. Or if you say, okay, they just have like, imagine $100 with our insurance, it's okay, forget it. Even living, we probably don't care that much. But if this person was, just imagine with 1 million with our insurance company going to say by next month, we can do this prediction with AI. Absolutely, we need to talk to this guy and with a different way. Even not only talk probably not enough. So we need to trigger these actions strategies. We can bring like the result to marketing. Marketing also includes call centers, and we can give tell when whoever's call, and we'll have all this information, do the focusing and tell people, okay, this person is so important. We don't want this guy to say bye to us. And then you probably, if they decide to say bye, you can tell them, okay, we'll have new products and these ones, and even like maybe another way to negotiate. So that's the way like how AI able to help marketing, scoring and ranking. And that's the way it's just I mentioned, like for the right wine, actually in real company, like insurance company will also have the same thing. Just imagine like people who get to like maybe have some short-term disability or long-term disability. We don't know how long for them to recover. You can do the forecasting, ranking them like these guys, highly likelihood going to recover, help these guys and to let them go back to work, go back to life, and we can save the money. Also, like also good quality for them, like to go back to work, go back to the real life. So a lot of things behind, and we're also able to do fraud detection, as I mentioned, like like in company, in bank, able to do like credit card. For insurance company, also the same thing. Insurance, they also have fraud. At least we say phishing ones. We can able to do detections. All these like people whoever's buy insurance, the fraud one always a small percentage, 1%, 2%, 3%, 5%, maximum 5%. But still, like you can't connect to everyone and say this person, I don't know, like just say if this is fraud or not. You should able to rank all these guys, choose to only like do some investigation for the top ones, maybe top 5%. And that's really reduce like the workload a lot. And pricing for insurance company, that's really something. We need to determine how much we want you to pay for insurance based on like personalized, like you're, as I mentioned, 20 years old. Just imagine you're 20 years old, the same height, same weight. For like 60 years old, 70 years old, same height, same weight. The mortality, I always say like the highly likelihood to be dead like in the next year should not be the same, right? So that's something like we are based on every individual features, or like we say the collected data. We can make decisions on price. Previously, as always, actuary have a certain way to calculate with their so many years Bible. They do the calculation. Whoever's the same age, maybe the same height and weight, they price everyone's the same thing. But from machine learning, and we can collect more information from each individual one. We can customize each individual a price, or even we customize an individual product a better price. So that's a lot of things we are able to do. That's what we call optimization of the pricing. Decision, underwriting decisions. I don't know if you understand underwriting. That's once you buy insurance and the people say approved, reject, that's the underwriting decision. Paul just mentioned that's the first underwriting AI model was built in life insurance in Canada. It's my baby, like I built it. So even now it's still on production, like still use it like in my company for so many years, even expanded to series, able to use for different underwriting, mortgage and so on. So specific for decision making, yes, no, approve, reject. Less classification use cases, right? So similar to apple and orange. So underwriting is a really good use case, and you make decisions, say approved or reject, and then I would like to say automatically replace human beings in a certain way. Specific, like a lot, big volume of prediction, like the decisions in underwriting are approved. That's like if we're able to detect, like with AI to do the classification well and to just approve automatically, save a lot of money, a lot of time, and a lot of efforts, even human beings' efforts. And so all these things, as just mentioned, like we not only provide the results, we're also like able to trigger some strategies or bring the insights. ChatGPT, that's the ones I added here as a new one, but a bit sensitive for me to talk about it because that's in progress in the company. We work on our own ChatGPT. So just showed here and mentioned, and also I think that's not news for any company. Like a lot of companies now working on their own ChatGPT, we call Gen AI, and to build to help business, help like from different way. So yeah, that's really in general like how we able to use structured data to help business, help insurance. All right, so give you one example, like still like even like now in industry are able to have some publications. This is like the publications I just mentioned, like the ones I do make a decision, underwriting decision, automatic system with AI, have this application, publication in I think 2020. So another was like now actually I'm taking care of like the finance stream in the company, and to help like kind of help CFO to with the AI solutions. So one of the we also have another publications last year, and to help the treasury operations, like to kind of similar to like your, just imagine your personal account, like how you manage your cash. So we manage the cash manually in the company. And also some unstructured data, as I mentioned, we are able to use AI to help to solve the problem. Like in even insurance company, as I just mentioned, documentation, paper-based stuff, a lot. You just can't imagine, like have a lot of documentation. Even still now have like the mails. And I remember like once I was in the company, like in Waterloo, like once we just see how like the mailbox, like the mail department work every day. It's so busy, so many mails. And that's, they mentioned that's only one segment, like a lot of things that happen still with paper-based. So, and also like the dental, as I mentioned, like the X-ray, and yeah, that's really a great applications with deep learning to just to do some detections, verifications, because every time we would have the claim, and from dentists, they have already have some like the comments, like the notes and mentioned that was the issue, and then then we just pay it. And now we just random choose like certain numbers and to see if that's correct or if align with the dentist. Imagine if we have AI automatically able to verify, and then probably we are able to maybe do all of the cases, or maybe much bigger portion of the auditing. For images, like also as I mentioned, like the iris images, like we collect all these not only for dentists, like pharmaceuticals ones, or like even like the health ones. So the image is also like able to like archived in insurance companies as well. And just imagine like if we just have iris images and able to detect like diabetes. So a lot of things like we are able to do similar to like the medical applications. Still, ChatGPT is also like one of the applications. Previously, I mentioned structured data. Just now, ChatGPT is also able to read like the tables, and you ask questions and they can interpret, even can able to do some calculations, explanations, and so on. And ChatGPT is also like, as everyone's now played with ChatGPT, like with unstructured, free, you have a lot of freedom to type in like your stuff, or you can give the pictures, or if you can like a different way to use ChatGPT. So that's the same way. And in the company, just we only want to apply it, or mainly apply it to insurance related issues or problems. So yeah, I don't want to mention that much about ChatGPT, and let's just give here like in general how these like the ChatGPT applied for the industry use cases. You see, like first one is the bank and financial services. That insurance company is part of that. Also, we have like the marketings, finance, and so on. All that can be applied. So last is about like, when should we consider AI as a solution? Just imagine like if any process need automation, like now a lot of manual work still like need to be done daily. This should like need to involve in human intelligence. These ones AI able to help and to consider as a solution. And some insights, like cognitive insights, you need to understand and what happened there. Probably you can make decisions by yourself or like someone else. At least you're able to interpret and see what's insights. Only give you a bunch of data, like it's nothing. So that part AI also able to. And also like cognitive engagement, as I just mentioned, like just imagine we have campaigns, alteration, like whoever's going to be in like with us, like in marketing. And we want to know what's in the future. We want to help out. Then we want to do the prediction, forecasting, recommendation. All these AI also able to help. So think of this way, like even like ask yourself, like which area you think AI able to help, and you probably can give some examples and also explain it. If that's with automation, if that's provide some insights or some engagement, whatever the way, and that should be really helpful for you to understand how AI can help in our real life or in even in your projects. So that's generally like what I would like to talk about today. And I also see the time. Yeah, let's have some discussions. I hope like you guys also have some questions and I want to have some discussions here.